Mainly, before we are explaining into the PDF flow, we need to learn a little bit about whatever the ASIC flow, how it is useful for in our VLSI industry ASIC flow. They are like some small, whatever the some mentioned as some small content. First one is the introduction. Okay, they are every flow or every project or every industry. They are the two. One is the front end and second one is the back end is there. But here in the VLSI industry, how it is going on? There, one is the front end, second one is the back end. This is the main two flows are present. Two flows is nothing but a two separate teams is available. Front end is nothing but a always we are preferable to coding, how to developing the automation and how to write into the code, RTL code. Okay, that whatever the some basic all the information is available in the front end coding related info. Back end is nothing but a physical info. Please, someone stop writing.
Okay, there is some spammer from other coaching institute. Just wait. Can anyone tell me the name of this spammer? Okay, sir, you can start. I am tracking it. Okay.
Yeah, okay, sure. Yeah, there are front end and back end flows are there. Okay, every front end and back end flows, okay, must and should require input file. Okay, some every stages is required some input flows. What we are given as the input file, we got some output. Once whatever we are working done, we can say the some output files. Those files will be included. Next stage input. Okay, those all are input and output requirement is there. And also next one is the inputs required to PD. Whatever we are explaining into the PD topics, right? Today, most of the case. Okay, what and all required in the PD inputs? What is the front end outputs? Okay, why we need to require into the inputs of PD? Okay, then initial checks of floor plan, power plan, placement, CTS, routing, then checks and optimization of each stage. Okay, not only for backend, like if in case some of the employees are working into the front end flows, at that time also we can cross verify the checks and optimizations. Optimizations and checks is nothing but it will be check that quality of the your designs and it will be identifying into the is there any specifications are meet or not. Okay, it will be show that one. Okay, then first this is the front end flow. Okay, how it is the working into the front end flow? Some first one is the specifications. Okay, specifications is nothing but a how the vendors they will defining into the some requirements. They want some requirement. We need they will specifying into the some features, some advanced features. Okay, then after that whatever the specifications, okay, we need to write a RTL code or VHDL code. Okay, then compilation. Then once the compilation is done, test that results will be tested, that specifications are met, then we can go to the compilation. Compilation is nothing but it will be simulate the whatever the RTL coding and VHDL coding is successfully, it will be meet whatever specification will meet or not. Next one is the simulation. Simulation before compilation and simulation, they are one stage is there. That stage is nothing but a architecture. Okay, all of you know, right? What is the architecture? It is the useful, like how we are working into the one NAND gate, how it is working. Okay, that is an one architecture related, one buffer, how it is working. Okay, how the transistor it is working. Okay, we are taken as the architecture and micro architecture. Inside the cell specifications, whatever the gate and the NVL, okay, those all are, it will be included into the analog stage or architecture or micro architecture. Okay, these three names we are specifying as the architecture. Okay, next one is the synthesis. Okay, in the synthesis stage only, there are multiple and in the synthesis stage only we can find out the timing issues and in your design output of the netlist. Okay, sorry, input of the PD netlist. Okay, we are able to find out in the synthesis stage. Then we can briefly go ahead about whatever the inputs of. Guys, please mute. Yeah. Now here, how to generate the gate level netlist. We need requirement is nothing but first we need to get the gate level netlist. PD input is nothing but a main netlist is gate level netlist. How we are able to find out? Okay, what are the requirements? First one is the RTL coding. Previously, whatever we are explaining, RTL coding is mandatory. Libraries. There are the multiple number of libraries are there. Lib, lef, techlib. Okay, and the gtechlib. Okay, just we are spreading into the just understanding purpose, basic concept. Okay, next one is the SDC. SDC is nothing but a synopsis design constraints, standard design constraints. Okay, there will be the standard. That particular values will be not changed. That whatever the connection, every macro or any cell, if in case they are the bulk, multiple number of transistors are there. So what is the transistors connection? How they will be connected into the inside the SDC? Those all the information we need to require as the input of front end. Inputs of front end. Outputs of front end is nothing but a mainly gate level netlist. They are the power info also is there, and timing info also is there. Okay. Apart from this one, main thing we need to require as the gate level netlist. We can explain each and every topic. Okay, each and every topic you can take 1 or 2 sections, then only we can clear. But this is an overall flow, right? Okay, like how it is the working. Okay, we can find out the gate level netlist in this one. What and all requirements, how we are able to find out gate level netlist. Then second one is the backend flow. Front end flow is done. Front end flow output is the gate level netlist, UPF, SDC, .def. Okay, the 4 files. Next one is the backend flow. Okay, backend flow, how it is the working. Okay, we got like coding, RTL coding. There the almost lakhs of lines are there. Okay, those lakhs of lines related to project. Okay, here, whatever your design chip will be dividing into the sub partitions. Okay, here remember there are the 3 steps are there partitioning. One is the top level, second one is the partitional level, third one is the sub level. Okay, chip level, sub level, partition level. Partition is nothing but a one partition. How it is the working on? Okay, most of the PD peoples will be everyone. It is not possible to handle multiple number of partitions one at a time. Okay, if in case easy projects we are seen into the industry, we can go through 1 or 2 partitions one at a time. We need to go into the fixing and connecting and the flows we are given. Then it is fine. But if in case their block will be the bigger, at that time not possible to handle 2 or more number of blocks. We can change that entire long block like anything but a okay big block we can defining into the sub levels or partition levels. Okay, at that time we can see the sub partition levels. Okay, tool whatever the partitioning is nothing but a chip level to partitions will be dividing into the individual ones. Then it is a partition. Second one is the floor plan. Floor plan is, remember, floor plan. Floor is nothing but a what? Whatever dividing into the chip, your partition, die and core area. Okay, how your design will be, how much requirement your core and die area, it will be specified, and also some of the info is there. Next one is the power. And also floor plan also we can place the macros or only cell some concepts there. But whatever the cell you are placing into the floor plan levels, Okay, that all these cells need to require as the power. Power means what? Power plant stage. Power plant stage power will be distribute the all equal power to standard cells and as well as your design macros. Okay, industry not calling as a macros, industry calling as the EBB. Okay, third one is the placement. Still now what we did, only macro placement and power on ground connections we did. Third step is the placement. Placement is nothing but to place the each and every combinational and sequential cells. Combinational and sequential cells is called standard cells. Standard cells will be placed in our design. Then it is called placement. Okay, next one, clock free synthesis. Okay, like standard, we know like how it is working into the standard cell, combinational cells and sequential cell. In the sequential cell, must and should one clock input is there. Okay, you can take the D flip-flop, DQ, D clock, QQ bar is there. Clock is nothing but a what? Clock need to connect, the clock need to balance. Where the tool is routed in the clock, CTS stage. Okay, in these two stages, placement and CTS stages, we can fix the timing violations. Okay, timing violations again means what? Okay, if your cell will be placed, that is in a macro or standard cell, one cell will be placed one location. Okay, in a that particular cell output is connected far away. Far away means nothing but a 10 unit micron distance. Okay, the violation will be like delay will be increased at some day, net delay or cell delay will be increased sometime. Okay, to meet that particular cell delay or net delay purpose, we can add the standard cells. Standard cells means what? And all of you know, like whatever the standard cells, AND gate or NOR gate and XOR, XNOR. Okay, those all our gates will be available in the libraries files. Okay, to fix the timing, setup, hold, crosstalk, and STA concept, there the multi number of STA concepts there. Okay, those different types of techniques we can use and we can fix the placement and CTS fixes. Okay. Then last one is the routing. Till now, floor plan stages, macros will be placed, macros and halos will be placed. Power plant stages, power will be connected every cell. Placement stage, standard cells will be placed. CTS stage, clock will be built. Okay, that macros and sequential cells and sometimes combinational cells to fix the timing violations. Automatically, tool will be placed the some combinational cells also. Okay, next one is the routing. Till now, there are the two routings is done. One is the power, second one is the clock. But need to route the signal routing also. Routing is the, now last one is the routing is there, right? Routing is the to route the signal entire the design. Okay, this is the routing stage. This is the main topic of ASIC flow. ASIC flow working into these conditions. Okay, next future slide, we can cross verify the how it is the going on. Next one. Before we are explaining, right? We are mostly focusing on the PD topics. Basic flow we are done. Now this is the main topic. PD inputs. Okay, mainly require gate level netlist. Okay, previously what we are seeing into the front end flow output gate level netlist we are seeing, right? Same gate level netlist we can require the input of physical design. Okay, second one is the library exchange format, LEF. Third one is the logical library. Fourth one is the SDC, standard design constraint or synopsis design constraints. Okay, Next one is the UPF and CPF. Like UPF, Unified Power Format. CPF, Complex Power Format. Okay. Next one, cap table or TLU plus file. The cap table or TLU plus file, R and C values are there. R and C, resistance and capacitance values in the delay. Okay. At this stage of parasitic extraction stage, this file information is more is there. More info is there. Okay. Last one is the every stage. What is the input output locations of the your design file? If you are placing into the we are using into the all the files, but which locations we are using and which location we got the output of the files. Okay, we are going to see the next future slides how it is the working into the every file. That is called gate level netlist or logical standard UPF. How it is the working? First one is the netlist. Okay, netlist. Netlist is nothing but a logical connectivity of your design standard cells and macros. Okay, it will be connecting logically. It will not connect any physically. Only logical connection is there. Whatever the gate level netlist logical info is there, same logical info only it will be applicable for in our design also. Next one is the library exchange format, LEF. Physical information is available. Okay, it physical available means macros and standard cells, every components, macros and combinational cells. Sometimes physical only cells we are seeing the PD concept, physical only cells, some of the cells. Those cells also physical info is present in these components. Next one is there are different types of LEFs are there. Technology LEF, technology related LEF is there. Next one is the standard cell LEF. Okay, just 2 to 3 minutes back we are discussing, right, combinational and sequences and how the library exchange format is physical info is available or not. Okay, whatever that cells info is there, physical info. Next one is the macro LEF. Okay, macros is nothing but a EBP. EBP is how the physical info is available, what and how many number of pins is there that particular cell, how many number of input pins or output pins, or is there any selection lines, or is there any clock connections is available or not in that particular macros. Okay, it is there or not in the physical information is available. Next one is the input and outputs. Okay, where the input ports our design present and where the output port, which place you are placing. Okay, those LEF info, input and output poles are LEF infos also present in this particular LEF layout exchange format, library exchange format. Okay, in the not only for library exchange format, layout exchange format also we can call. Okay, layout is nothing but a physical info is present. Okay, layout is nothing but a physical info is present. Okay, next one is the logical library. So just now we got physical library. Next one is the logical library. Physical library means LEF, logical means library, lib. Okay, here logical library, functionality and timing related info. Each and every component, whatever we are defining into the our design input combinations. Okay, timings and functionality information is present, all the components. Second one is the power related information for each cell. Okay, it will be include your design combinational and as well as sequential cell. All the combinations of the power, how much required, those powers will be available. Functionality is there, right? With functionality, it will be include the power related info. That particular cell, how much leakage. If in case we can consider as the one combinational cell or one sequential, any one cell. Okay, how much it will be required leakage power. Okay, how much that particular cell will be made. Okay, those all info is available in the power related info. Next one is the max fan out. Max fan out is nothing but how much that particular cell driven by the input nets or output nets. Okay. Example, this is the one cell. Okay, in this particular one cell, okay, their concept we can mention. I mentioned like just only fan out, but one more concept is there, fan in also. Fan in concept also. Fan in is nothing but how many number of cells will be. Like see, the example I mentioned like 4 cells. Okay, in the 4 cells, only one input pin will be drive or not. Capacity is there or not in this particular only one net. Okay, tool will be checked like fan out info, logical libraries is there, right? In that logical libraries, inside the logical libraries only we are find out it. Okay, whatever the 4 cells will be, it will be drive the fan in or not. Tool will be checked. Next one is the max fan out. In industry, whatever the upcoming or present days, we are working into the multiple blocks, right? We are always into the fan out violations, max fan out. Okay. Now fan out means what? Okay. Now this is also one combinational cell. Okay. In this combinational cell, how many number of cells will be drive? Example, this cell drive strength is the 16. Okay. Maximum two drive strength of cells will be driven by the 8 cells only. Okay, 8 into 2, 16, right? Only 8 cells will be drive. If in case extra cell will be connected, but logical connection will be the same only. Okay, logical need to connect this only one cell, but here 9 cells is there. 9 cells is the connected in this location. How the one extra cell is added, right? How to remove? Okay, those all information we can fix the placement and the CTS, but how we are able, whatever the content info is available. Okay, in the logical fan out only we can explaining into the concept also. How it is the 9 cell will be drive. Okay, we need to add the some more buffers, or we can add the some high drive strength of cell in this input pin. If you add the high drive strength of input pin, it will be resolved, or we can add the one buffer to drive this particular cell. It will be driven by the 1 or 2 cells. We can dividing into the 2 steps like. Okay, totally 9 cells, right? Like 6 cells will be the direct connection. Remaining 3 cells will be the, we can add the one buffer. This is the way to we can cross verify the fan out and fan in. Okay, in the real time. Okay, next one is the PVT conditions. Okay, next one is the PVT condition. Processor voltage temperature condition. Okay, PVT, processor voltage condition. Okay, in this logical library only, we got like PVC conditions, right? AOCV, OCV, AOCV, POCV, how the condition is working on based on the those condition. Okay, that condition and based on the your design tech node. Okay, processor voltage and temperature values is available in the logical values. Okay, third one is the cell footprint. Any one of you know cell footprint? Okay, cell footprint is nothing but a every do you have any one of you know lookup table? Lookup table. Okay, I will tell you. Okay. Lookup table is nothing but the table will be useful to cross verify the net delay and cell delay in the design. Okay, tool logically connected. How much net delay is there? Multiple number of lakhs of cells are there in the design. Okay, every cell, how much one particular cell net delay, how much cell delay, how much capacitance, how the input delay it is working, output delay how it is working. All the info is available in the cell footprint in the library file. Okay, we can show the in the practical time how the values is available in the footprint. Okay. Okay, next one is the SDC, standard design constraint. In the standard design constraint, clock definitions. Clock definition is nothing but a how many clocks, how many main clocks is available in the design. Okay, how many generated, how many master clocks is available our design. Okay, those clock definitions is available. Okay, next one is the input and output delays. Okay, it is not related to standard cells or combinational cells. It will be related to in our design clock cells. Okay, how much the input and output delay and output delay is available. How the timing exceptions is there. How many types of timing exceptions is there. Clock exceptions is there. Okay, timing exceptions is nothing but to fix the data path only. Clock exceptions will be the to fix the clock path. Okay, next one is the clock uncertainties values, latency values, DRV. Okay, DRV is nothing but a design rule violations. Okay, some of every tech node also we can use the some DRVs in the design. Okay, those DRV values also is there. DRC will be different. DRV is the different. DRV design rule violation. DRC design rule check. DRVs we can always see the PD, SD. PD is nothing but a physical design. SD is nothing but a static design, static timing analysis. Okay, DRC, one concept is the DRC, that is called design rule check. Okay, in the DRC violations we can see in physical verification stage. This is the two difference. Next one is the UPF. UPF is nothing but a simply power related info. Okay, next one is the cap table and TLU plus, right? It will be whatever the tool will be constrained, transmission capacitance and resistance values of the delay is there. That is called interconnected delay. How the one input and output connection is there based on the wire need to require. Wire is nothing but a metal. That metal, every metal also transmission values are there, resistance values are, capacitance values also there, resistance values is there. Those need to combination we can defining into the TLU plus and mapping files. Next one is the input output location file. Okay, previously we are already did like information about the where in our design input and output pins or input output pads using into the design. Okay, pins and the pads will be the different concept, but in the top level, based on the top level, we can call as the partition level pins. input pins and output pins. Okay, based on the your partition level, we can see the input output pads. Okay, this is the two pins and pads will be different concept. You can remember. Next one is the net list. We are always in the gate level net list, right? In the gate level net list, how the gate level net list is working, we are already done. Once the all the files we are dumped in our design, after that we can cross verify the some initial check. There are 3 to 5 checks are there in the present, whatever I mentioned, but multiple number of checks is available. We can explain that each and every one. First one is the netlist check. Okay, first one is the netlist will be check. Check underscore netlist is the command to check the netlist quality is there. Quality is the good, whatever the specifications and whatever the gate level netlist will be specified, both are equal or not. If in case we are seeing that any fan out violations or fan in violations or multi-driven nets are there, or in that particular non-clock paths is available or not in the design, or empty modules is there or not, and the black boxes. Okay, black boxes also is there or not. Tool will be checked that entire the netlist info in this netlist check. Okay, see here netlist unequalizer. Okay, that netlist is equal or not compared to specifications. It will be check the specifications and your front end input. Okay, front end input and output, and as well as whatever you are dumping the file, netlist file, those two things will be compared. And if we are seeing that any differentiation in that netlist file, okay, it will be displaying into the that violation category. Okay, example, I have mentioned like unequalizations, no fan out, no fan in, multi-driven Ls, max fan out are there or not, whatever the assigned statement, if in case are you assigning into the any specified connection of our design, it will be displaying into the netlist levels. And also clock cells. Okay, in that clock cells, non-clock path, that cell will be the clock cell only, but that clock path is not there. If in case clock path is not there, it will be displaying like that error. One error will be displaying. Okay, empty modules and black boxes. Okay, empty bottles and black boxes also, if in case the netlist is available, is there any present in the design, it will be displayed. If both are whatever front end output and whatever you are dumping the file, both are equal, there is no issue. If you are seeing that any differentiation in the design, we can cross verify the netlist owners. Okay, we can cross verifying into the netlist owners. Next one, timing. Okay, for timing check. For timing check, what we are check, it will be check the setup and hold timing, and as well as removal and recovery and removal. Setup and hold timing, it will check the synchronous path only. Asynchronous path tool will be cross verifying into the setup and hold, and as well as recovery and removal also in the timing checks. Okay, this command for to check the timing means check underscore timing is the command to check the timing checks. Next one is the SDC. Okay, synopsis, standard design constraints checks. Okay, in the are you able to see my screen?
Yes,
Yes, sir.
Yes, thank you. Okay, SDC, standard design constraints check. Okay, it will be checked that in our design on clock registers. Okay, that registers is available, that of clock related registers, it is not connected. It will be displaying into the how many number of clock is not connected, if it is unconstrained endpoints is available or not. Next one is the input output delay constraint, multi-clock driven clocks. Okay, missing input port. Okay, sometimes if in case whatever the input connections, output connection need to require. Okay, that connection will be in the SDC. But is sometimes how the tool is performing, that connection, some logic will be missing. Okay, at that time tool will be displaying like, okay, this connections, whatever the input pin and output pin. Okay, this connection is the that it will not connected. Connection is missing. It will be driven by the it will displaying into the some error category. Okay, related to all the clock related info we can see into the SDC. Timing related, timing checks we can see. Okay, like depends upon the different checks we can defining into the whatever the VLSI will be defining into the different sanity checks. SDC will be the different check timing will be the different, check UPF will be the different, check UPF also is there. UPF is nothing but means what? Power UPF. Okay, like this is an single voltage area or multi voltage domain, or is there any specified powers is required or not? It will be displaying into the UPF also, but I didn't mention in that one. UPF also is the main command. Okay, next. Okay, next
Sorry.
we can. Yes, go ahead.
If any, if
Ask it out in the chat box. Ask it out in the chat box only. For ask in the end of session.
Yes,
So that
please.
you can continue. We will remove you if you unmute yourself. Thank you guys. You can continue with something.
Thank you. Yeah, next one is the partitioning. Okay. Okay. Previously, what we are designing, they are the what I'm telling, like they are the larger blocks is available. Okay. Total chip is there. The total chip will be dividing into the some small blocks. Then it is called partitioning. But we can see the chip level. Okay, chip level, sub level, partitioning. Okay, chip level. Okay, we can see here. Okay, here chip level, how it is the working on total design, total core and area, total your design chip will be this particular specified area. Okay, next one, sub level is nothing but a one group of partitions, like 40 blocks are there in the total chip level. Okay, tool whatever the chip top level. Okay, chip top team will be dividing into they are partitioning into the 4 sub levels. Okay, source of 4 sub level, like one sub level is the 10 partitions, second sub level is the 10 partition, third with 10 partition, fourth sub level is the 10 partition. Okay, they are totally 40 blocks. In the 40 blocks handling into the 4 persons. That 4 persons is the sub level team. Okay, next we can consider as the one sub level. In that one sub level, how many partitions are there? 10 partitions. Okay, then this is then a 10 partition. These 10 partitions will be okay. These 10 partitions, every partition should be follow the all the steps. Whatever we are defining, right? All the steps. Okay, once your partition is done, we can follow all the steps. Timing will be made. Your sub-level team also is there, right? Sub-level team. They are the 4 members. 4 members also, they will follow the same procedure. Okay, same procedure, but they, some changing into the metal layers will be defining different. Okay, so only for metal layers will be variation is there. Apart from all the procedure will be the same. Okay, in the 4 peoples we can combine and we can gather that 4 blocks into one chip. Okay, this is the partitioning tool. Will vendors will be defining into the different partition. This is the way to tool will be dividing into the sub blocks. Okay, here if we are dividing into the every partition, okay, that partition PNR flow easy to handle. Okay, some compared to previously 1 millions of transistors are there. Now lakhs of transistors are there. Lakhs of transistor will be the, it will easy to handle the PNR flow. Okay, and also it will be taking as the less time. If your chip is more, is there, time will be very high, right? Okay, that's way we need to requiring into the very less time only we can complete the small blocks. Okay, that's way we can specify into the small block. Okay, features will be the whatever the defining into the partition, it will be easy to handle the PNR flow and easy to handle the, okay, entire the PV and as well as STA also. Okay, it and also with less time. That is called a partitioning we are defining. Okay, all the partitions, every partition will be defining into the 2 or 3. Every project also tool will be defining multiple number of partition. Easy to that flow runtime will be saved. To fix the timing analysis purpose, some multiple number of cells we are adding. Those purpose we can changing the whatever the we can saving the our time and as well as flow time. We can dividing into the small blocks. That is the main target of partition levels, partitioning. Next one is the floor plan. Okay, in the floor plan, mainly, okay, the initial of the PD flow, total overall flow also, we are discussing the same thing. Okay, how we are explaining into the floor plan. There will be the must and should, whatever you are, all the files you are dumped our design, we are seeing that check. In the checks we are you are not able to see the any violation, we can proceed to go the floor plan. Okay, in the floor plans also we can defining into the core die area estimation, how your design core and die area. Next one is the how much your design macro placement. Okay, how you are placing into the macros in our design. Okay, next one, input and output ports, how you are able to place. This is the 3 estimations need we can require: size, macro placement, input and output ports. Okay, once these all are done, whatever the estimation and the placement, macro placement and ports placement is done. Okay, we need to check the congestion, aspect ratio, blockages. Congestion will be the how much congestion is required. Okay, aspect ratio mean if we are defining into the any aspect length and width, how it is present, ratio of the your design. Blockages, how many types of blockages required the our design. Halos, okay, what and all halos need to add. Physical cells, okay, what type of physical cells we can add. Checks, okay, checks is nothing but some sanity checks. Output is nothing but a floor plan output. Okay, how it will be performing. Okay, this
Hello,
is
sir.
yes.
Halos and keyboard margin are both the same, sir, or different?
In halos and keyboard margin are some small variation is there.
Yeah, sir. What is the difference, sir?
Okay, once this one is done, then we will go ahead each and every question. You can post in the chat box. You can
Yeah,
come
okay,
more.
sir.
Okay, and halos and physical cells, and once we are all done, our technology will be good, then we can check the sanity checks, and then next one is the we need to dump into the output files. Okay, how we are able to estimate the your design die size estimation, die area and the core area. Okay, now see here you are seeing, right?
The aspect ratio. See, you are saying, right? This is an core area and die area. Die area is nothing but to protecting into the your design die area. Okay, to protecting the core area, we can defining into the see whatever I am highlighted in the design, right? Now see, this is the first one is the core area. Core area is the main line of the inside the partitions. Okay. Die area is nothing but a to protect the your design core area of the cells inside the core area of the every cells. Now here next one is the input cells and output cell, input cell or input output pads we are seeing. Okay, those are the cells will be placed in the core area boundary. Okay, in the present days and nowadays technologies, we are using that boundary cells. Okay, we can call as the boundary pads also. Okay, those all cells will be placing into the our design. Next one is the okay, next one, whatever we are seeing, right? In this one. Okay, this is an cells. That cells will be placed, whatever the macro cells you are placing, right? Macros only. Now we are in the floor plans. Always whatever that these four we are seeing, we are drawing right inside the cell, inside the core and area. This is the macros. Macros, how the placement is going on. Okay, next, whatever the all the input pads and core area, how the tool is defining and the corner cells. Okay, and also core area, all the cells, whatever the inside is available, then it is called core area. Whatever the inside, whatever the core cell is there, right? Corner cell. We can see the corner cell one pick, like I will draw here. This is the one, right? Okay, inside the whatever the cells is available, those cells will be in the placement stage we are placing, and sometimes the placement stage and CTS stage, routing stage, based on the cells and routing will be placed in this die area only, die and core area only. And between the die and core area, sometimes power connections. In the power plant stage, we are seeing, right? Power connections, routing also will be placed. Okay, those connections, how the estimated the our design, how much percentage or how much unit microns we can give. That is a main important. Okay, now see here how defining into the full chip height. Your chip height, how to defining? Okay, core height plus core to input output spacing. Input pin or output pin spacing is there, right? That spacing into 2 plus 2 into input and output pad height. Every ports also some height and width is there. Okay, whatever the your core area to, okay, input and output spacing is there. Okay, core area to input output spacing is there. That spacing we are find outing into the full chip height. Full chip width also same. Core width plus core to input and output spacing into, we can defining into the sum of the these formulas. Okay, we can easy to find out into the full chip. Okay, whatever the estimation of your design core area also same way too, we can proceed to highlight that one. Okay, now proceed to calculate the your estimation of the die and core area partition levels. Okay, once the core and die and estimation is done, we can see the congestion. Next step is the congestion and blockages. Congestion is nothing but a okay require whatever the requirement metal layers divided by available metal layers. Requirement is the 10 metal layers required, but available is the 5 only. 10 is the requirement, but available is the 5. But need to require 5 metal layers in that area. Okay, let's see. See here. This is the one area. Just you can consider as a one. This is an area. In this area, only 5 metal layers routing is availability is there. But whatever the actually available metal layers, 5 only. 5 only available. But how many require? I need to require 10 metal layers. But remaining 5, how to route? Remaining 5 metal layer, how to route? This is the congestion. Okay, congestion, how to identify? Requirement metal layers divided by available of metal layers. Okay, we can fix the congestion, but we can cross verify the your design input and output of the macros. They are the multiple. They are the 40 or 50 macros are there. Those 40 or 50 macros cross verify the connections. How many number of connections is present? Input connections and output connections based on the fly lines. One concept is there. One fly lines concept. Okay, those fly lines concept we can place the our design macros. Next one is the blockages. There are 2 types of blockages is there. Placement blockages or routing blockages. Okay, this is an not a simple concept blockages. Very lengthy concept is there. Placement blockages will be defining into the 3 types. Routing blockages will be defining into the every metal layer blockages. If for example in your design 12 metal layers, 12 routing metal layers are there. In the 12 blockages is available. Okay, 12 13 blockages is available. Okay, I will explaining into the next future slide, future classes, how the blockages is working on. Okay. Next one is the halo. Okay. Okay. Halos, how we are find outing number of terminals. Okay. If you are design, how many number of terminals? Here again, one more concept is there. Okay. Concept. Terminal, ports, pins, pads. Okay. Terminals. First one is the terminal. Second one is the port. Third one is the pin. Fourth one is the pads. Okay. Every terminal, every whatever the terminal and port combination is called port and terminal. Okay, port and terminal. If your design terminal is there, definitely port is there. If in case you are find outing into the port, okay, if in case only for port is available, terminal is missing. Okay, at that time tool will be representing like error. Okay, in this location, terminal is missing. Port is there, but terminal is missing in this location. Okay, at that time, we can define the physical design guys only. We can define the terminal also in this case. Pins and pads we are explaining. Pins is nothing but a floor plan pins is nothing but a input and output. Top level inputs, partition level pads. Top level team they will call as the pins. Okay, in the partition level we can consider as the pads, input and output pads. Okay, this is the main differentiation. Next one is the aspect ratio. Aspect ratio is nothing but a height by weight. Okay, how much your core height? Okay, core height into weight. Height divided by weight. This is called height. This is then weight. Okay, tool will be defining into the aspect ratio also. Okay, in the floor plan, whatever we are explaining into the logical floor plan only. Till now, logical floor plan. There, the physical floor plan is there. That physical floor plan is a very less concept. Once this done, we can show that one also. This is the aspect ratio we are finding out into the technology infos. Okay, this is the main targets we can cross verify. Next one is the macro consideration. How the macros will be placed in our design. Based on the, I'm always telling, okay, based on the fly line analysis, macro placement is done by the based on the fly line analysis. First concept is the fly line analysis. Okay, second one is the periphery. Periphery is nothing but a, okay, one group of macros is there in the design. Okay, like there the 4 groups is available. 40 macros are there, 4 groups of macros are there. Okay, let me go ahead here. 40 macros are there. Okay, in this 40 macros, 4 groups of macros is there. One group of macros, 10 macros. One group of macros, 16 macros. One group of macros, 20. Okay, 20. Next group of macros will be 4. Okay, if in case this group of macros, 4 or 5 groups of macros is there. Periphery of the design means this 10, whatever the one group of macros, 10 macros is there, right? These macros need to place one macro behind to one macro. Okay, one macro behind to one macro. Okay, always multiple number of one group, right? One group means multiple number of connections is there. Okay, who can cross verify the periphery of the cross verify the connection of macro groups. Next one is the fly line analysis. This is the main 3 based on the 3 guidelines we can choose to place the in our design macro placement. Okay, this is the main target to place the macro placement. If we overall what overall chip macro placement is good, your block will be good. If your macro placement you are changing into the some small macro or some small issue you are created. Okay, total timings and PV or routing or whatever the specification. Okay, last stage is the tape out stage. That is tape out stage specifications vendors they will check. Okay, at that time the design will be the collapse. Okay, based on the macro placement only, total design will be depending. Okay, that's why macro placement is the very crucial stage. Need to take and place the macros. Okay, this is the macro placement. Okay, next one is Okay, this is the input and output connections, how the macro communication, one macro to one macro. We are defining, right? Periphery, whatever the periphery of the macro mean, core area only, area only we can place, core side only place, and group of the macros will be placed behind of the macros only. Okay, and this one macro multiple like 20 or 30 connections are there. Those 20 or 30 connections, it will be proper way to connected or not. We can see. Okay, if in case like see here our input connections and output connections, how the tool input connections means what? Whatever the your design input port to your design input pin, and here output port means what? Okay, that particular cell output pin to output port, how the connection is going on. Like this is an basic diagram we have mentioned. Once the shell will be open, we can see the how the performing in our design macro communication and any cell communication in the design. Macro communication is there, port communication is there, standard cell communication, and the flop communication, flip-flop communication, how it is the present. We can see in the just concept we need to same thing, whatever how the connection is going on, input and output connections is the same thing only. Okay, how the macros we are placing. Previously we are defining right periphery of that one, and see this one also we done how the macros to standard cell connections, macro to standard cells, like we are always defining into the fly line analysis, right? This is the fly lines. Okay, how the your how your design will be connecting into the fly lines, that is called standard cells, macros, ports. Connection is going on, how the connection is going on. Based on the fly line analysis only, we can place the macros. Okay, next one, physical cell. Physical cell placements in the floor plan stage only. Okay, in the main use of this physical cell. Okay, main use of the design in floor plan stage physical only cell. Okay, main reason. Okay, cell will be placed. Multiple number of physical cells is available, but what is the reason we are explaining? Okay, here physical cells will be. Okay, it will always physical cells will be placed into the periphery of the design. Periphery in the all around the core area tool will be placed with the some cells. Okay, present technology is going on. Whatever the Intel, TSMC, ADM, and Synopsys. Okay, some of the specified cells. Okay, I am seeing that most of the projects I am seeing into the decap cells only, but cell name is the decap cell, but that functionality will be the boundary cells. Functional will be variation is there. Functionality, how the working condition of the functionality will be the boundary conditions. Tool will be defining. Okay, why in most of the cases decap cells we are using, right? Now that decap cells will be the useful to changing into the poly. Okay, some that library vendors they will defining into and they will developing into the poly of the layer that particular cells. If okay, all the physical only cells is available poly, but okay, it will not connected somewhere. Okay, but in this periphery of the in this end cap cells, okay, whatever end cap cells in the design, okay, we can place into the our design core area. It will be connecting into the periphery, poly periphery and OD. OD is nothing but a oxide diode. Okay, oxide diode is available in this area. Next one is the between that whatever we are seeing into the some layers, some lines. Now we are seeing right. We are seeing some lines. Okay, between the whatever the straight horizontal lines we are seeing right, then it is called as side rows. Okay, side rows we are seeing. Okay, side rows is nothing but a tool will be every standard cell every standard cell will be placed between the site rows only. Okay, why this between the site rows only it will be placed mean? Okay, that connection, whatever the power connection is, power connection, standard cell site rows to top metal layer. Top metal layer is nothing but based on your project. M12 is the top metal layer. That M12 also connection is there. M12 also power connection is there.
So guys, there's one spammer from like Master VLSI, something like that. He's like constantly creating a noise in the like our sessions. He's defaming us on the like his name is Vijay, I guess. Yeah. He's like constantly making the noise in the like sessions and all. So just ignore him, guys, and please support us. Right? This guy is constantly making the links in the session. Yeah, I'm doing that person also. Their fees is also 95,000 they are charging for this complete course. Okay, yeah. Yeah, you can continue, sir.
Thank you. Okay, this is then a standard. Next one is the standard cell site rows. We are easy to find out in every design. Standard cell site rows full. Standard cell site rows only. Every combination cells and sequential cells will be placed. But sometimes not only for combinational and sequential cells. Okay, sometimes what they call some ODI double heighted cells. Okay, in the design double heighted cell. That double heighted cells also we can consider as the standard cells only, but there will be the separate library. Okay, there will be the separate tech leaf is there. Okay, your ongoing project we can explain that in more depth, more concept, but here I am explaining that how the double heighted standard cells also it will be used. That is the main. Sometimes double heighted standard cells will be the functionality will be the same, whatever the functionality will be the logical connection, physical connection same, but whatever the functionality specified, like timing purpose to store the any value, the timing purpose, or to store the clock purpose, the timing values will be some specified spine related cells. Spine, remember spine is the main topic at the time of CTS stage. Okay, we can see this is the standard cell library. Next one is the standard cell library characteristics. Okay, characterization or characteristics. Standard cell library. Standard cells we are seeing the site rows, right? Standard cell, how the standard cells will be placed. In the standard cell site rows only end cap cells will be placed. Okay, these all are in the end cap cells. Okay, end cap cells brief info. Next one is the well tap cells. Well tap cells is nothing but to prevent the latch up issue. Latch up issue is nothing but a power and ground connections. Okay, to resolve those latch up issues, we can use the tap cell. Okay, tap cells is the not only for resolving into the latch up issue. Sometimes we are resolving into the NW. In the initial of the project, I'm telling that one NW issue. That NW issues also it will be resolving into the latch up well tap cells. By using well tap cells, it will be resolving into the NW violation. Okay, NW is nothing but a annual violations. Now don't think the different concept. NW is nothing but a annual violations. Okay, simply. Okay, working condition. And the next one is the checks. In the floor plan, what and all need to check. First one is the unplaced macros. Okay, unplaced macros, how we are able to find out? Now we are seeing the standard cell site rows, right? In the standard cell site rows only standard macros also need to place. If in case, okay, some small variation like we did like this one. Okay, macros is not placed, unplaced macro. You inside the core area only, but unplaced the macro. But if in case this is the core area. Okay, in this core area, out of the core area, 40 macros is there. Total 40 macros in the placement stage. You placed 36 only, 36 macros only. Remaining 4 macros out of the core area. Okay, behind the core area is there. Okay, if in case behind the 4 areas this macros is there, we can see the unplaced macros. Or not only for this one, if in case 40 macros will be placed inside the core area, but that cell will be not placed in the site row. Okay, that cell will be, whatever the macro will be not placed in the site row, we can see the unplaced macro. We can see these many violations. Okay, we are easy to find out. These guys will be the proper floor plan is done. Proper floor plan is done or not. There it will take only 4 to 5 minutes only. How he's doing well. Okay, these guys is the real way to this guy fixing or not violation, all the category of your design violations. Okay, it will be checking the 2 to 3 minutes only, higher experience guys. Okay, next one is the overlaps of the macro. Overlaps is macro means one macro will be you guys all are know like overlaps how it is going on. This is an M1. M1 is nothing but a macro one. This is an M2 macro. M2 macro. Okay, these two will be the overlap. Okay, is there any overlaps in the design? Must and should 90% we are not able to see in the overlaps in the macros, but unplaced macros we can see in the industry. Okay. Next one is the pin assessment. Pin assessment is nothing but we are placing into the input and output pins, right? Those pins and input and output pins is properly placed or not. Okay, if in case is there any pin missing or any port missing? Okay, is there any terminal missing? Okay, we are able to easy to find out into these checks. Output files, def and .v. Def is nothing but a design exchange format.
Yes, you are audible.
Yes. Thank you. Then next we can see the power plan. Okay, in the power plan is nothing but a process of to place the power connection every standard cells and every macros in the design. Only one sentence. The power plan is nothing but a power will be distribute the power all macros and all the cells in the design, VSS and VDD connections. Okay, based on the UPF. Okay, based on the here one input is there, right? UPF. Based on this particular UPF, we can see the single voltage or multi voltage, single voltage domain or multi voltage domain. If you open the UPF and cross verify, it will be the 2 voltage domains or single voltage domain variation is there. Okay, whatever the floor plan inputs plus UPF. UPF and CPF is not the complex power format, UPF unified power format, power plan. Okay, these all are the inputs. Okay, it will be distribute the total design, standard cells and macros, distribute the power in the design. That is the main target to power plan. Okay, in the power plan, one small structure is there. Okay, power pads. Like we can see we can draw the one here, then it is the useful. This is the your design core area and die area. This is the core and this is the die area. Okay, here port in power ports will be placed. Example, I'm mentioning as the only one port. Power pads. This is the power pads. Okay. Second one, core ring. Core ring is nothing but a core area and die area around ring will be created. Okay, not only for core ring, macro ring also. Design 40 macros is there. In the 40 macros around also ring will be created. Okay, a ring structure like how it is working into the core ring. Okay, whatever I'm drawing into the one line, right? That is not a line. That is called wire. Wire is nothing but a metal. Okay, Next one is the straps, strips. We can consider as the strips. The strips is nothing but a horizontal and vertical metal layers. Okay, total design, not only for this one, total design, horizontal and vertical metal layers is there. Whatever your design core area, if you are working into the one partition level, that partition core and area connection is there. Next one, flow pins. Okay, following pins, whatever the following pin. If you are following the pins, you can remember as the pins. In this pins is mean, okay, macros, power pins also is there. Every standard cell pins is there. Okay, how the connection is going on every standard cell based on the strips and also based on the your design standard cell side row connections. Okay, power mesh. Okay, power mesh we can able to draw. If we are drawing into the mesh analysis, all the, power will be distributed equally into all the cells, standard cells and as well as macros based on the pins. Okay, next one is the standard cells. Okay, just now we are previously we discussing, right? Standard cells will be placed. If you are, this is an A, you can mention like this one and this one, side rows. Standard cell side rows. Okay, in the between these two, okay, between these two, standard cell will be placed. Okay, standard cell. Okay, in this standard cell, okay, only one standard I am explaining. That particular only one standard cell is only one standard cell. Power and ground connections is there. Power and ground mean example above is the VSS. Okay, VSS. VSS means what? Ground. Connection will be the ground connection. Ground connection pins is present. Entire the horizontal line. Okay, ground connection is there. Okay, next standard cell, whatever the side rows will be there, right? This is the VDD or VCC. Both are same. VDD and VCC are same. Okay, that is a power purpose only we can consider as a VDD and VSS. Names will be the different. Okay, if in case single domain is there, VDD is the single name. Multi power is there at that time. VDD is the one power domain. VCC is the one another power domain. Okay, based on the your macros analysis only power domains will be defining. In the power dome, whatever the UPF defining only power will power plant stage, power will be distributed. Okay, same structure only. Okay, this is the power related infos. Okay, next one. Okay, next one, core pad. Okay, see core power pad. Whatever whatever we can see, right? Pads. VDD, VSS, VDD, VSS, VDD, VSS. This is all our pads. Previously we had already done. Okay, this is the core ring. How the ring is ring type. Core ring is nothing but a ring type. Power connection is there. This is an power pads to ring connection. Okay, this is the 2 is the power. Okay, this is the power pad. In these pads to how the in the design core ring connection is there. Okay, not only for core ring, macro ring also it is available. Okay, in the mesh in the power plant state. Okay, straps, whatever I am explaining, right? Straps is nothing but a horizontal and a vertical. So entire the design, horizontal and vertical connections is there. Okay, next one, flow pin. Flow pins, previously we are discussing, right? Standard cell site row, flow pins is there. One is the VDD, second one is the VSS. One is the VDD, second one is the VSS. Third one is the VDD. Fourth one is the VSS. Okay, VDD and VSS, parallel connections is there. Parallel metal layers is there. Flowing power flowing connections also same thing only to the pins of the standard cells connection. Okay, in the power plant stage, mainly we can check that what is the your design fire drop. Okay, next one is the power. Whatever the power will be routing is done. In the power routing, is there any opens or shorts is created? Okay, we can check. Third one is the power plant outputs. Okay, this is the name power plant def and power plant .v. .v is nothing but a netlist. .v is nothing but a netlist. Def is nothing but a design exchange format. Okay, this is the power plant output. Okay. Richard, shall we complete all the topics today or we'll complete tomorrow?
Just complete tomorrow, no problem. This is
Okay,
fine for
Richard.
the first class.
Yeah, like till now, whatever the basic concept of ASIC and floor plan, power plan is done. Next remaining 3 topics are pending.
Sure, we will do it tomorrow, no problem.
Okay, otherwise it will go into the very lengthy topic, right?
Exactly. They will get saturated also. Yeah.
Yes, Richard.
Okay then. Thank you, sir. Thank you, guys. There is one spammer. See the
I
spammer.
don't know who is that
They
guy.
are from some expensive coaching institute. I don't want to take the name, but they are charging 1 lakh rupees for these courses. What we are giving in 20,000.
Okay.
They have joined using different WhatsApp group and they are joining the. Okay.
Okay. There are always some concept will be returning. Some lines, yes. Okay, let's see. Oh, okay.
Yeah. Okay. Thank you, guys. Thank you so much. So let me take the queries. Anyone have any doubt? Any query?
Both are okay. Halos and keyboard margin both are same, but some small variation is there. Okay. Keyboard margin. First one I'm explaining that keyboard margin. It will be useful to create the macros, and if in case it will be useful for some specified cells. One at the time of SPC file, I think I am explaining that one concept, spine. Remember that one, spine. Okay, some of the cells, spine cells also we can require the keyboard margin. Okay, we can draw the both macros and as well as standard cells. We can draw, but halos is not this concept. Halos will be we can create only for macros only. Macros. What is the use of halo? Okay, to fix the routing congestion in placement stage. Sorry, in floor plan stage. Sorry, not in placement, floor plan stage. To fix the routing congestion in floor plan stage. Okay, is that clear, guys?
Yeah, it is clear now. So can we stop the session?
Yes.
Okay,
yes.
fine. Thank you, guys. Thank you so much. And if anyone have any query, just WhatsApp me anytime. I will reply. Okay, then. Thank you, guys. WhatsApp me if you want to attend the next session also. Otherwise, we will not include you for the next session. Just WhatsApp me for the next session if you want to attend the next session. Thank you, guys. Thank you so much.